Okay, good afternoon. So today we are going to start the unit number 8, that is column base. Column base. It means we have to design the column base. In steel structure we are calling as a column base. In RC structure we are calling as a foundation or footing. So whatever we have designed the column in the unit number 4, for that we are providing here base. So base is of the steel and concrete. So we will see how the look column base, what is column base or what is base plate for the column, and then we will design the column base. So before uh, see the column base structure, so we will define what is base plate or what is column base. So generally the the load transmitted by column on the concrete pedestal, load transmitted by the column on the concrete pedestal through an attachment provided in between the column and concrete pedestal, called as the bearing plate or the base plate. So I will show you by the sketch what is actually we are calling as a base plate or column base. So before that I have told you the definition of the base plate or column base is the load transmitted by column, the load transmitted by column on the concrete pedestal through an attachment provided in between the column and concrete pedestal is called as a bearing plate or base plate. That is the column base. So there are two types of the column base. So before that, first write down the definition of column base. Here, the because one of MCQ will be asked on the base of this definition in examination. One MCQ asked on this definition. So write down definition. The load is transmitted. The load is transmitted. The load is transmitted by the column. The load is transmitted by the column on the concrete pedestal. On the concrete pedestal through through an attachment provided, through an attachment provided, attachment provided in between, in between column and concrete pedestal, column and column and concrete pedestal, column and concrete pedestal, called as, called as bearing plate or base plate, bearing plate or base plate. So what is bearing plate or base plate? The load is transmitted by the column on the concrete pedestal through an attachment provided in between column and concrete pedestal, called as a bearing plate or base plate, and that bearing plate and base plate we have to design here. This bearing plate or base plate we have to design here. So there are two types of column base. generally. So the column base are having two types. So first is the slab base. This is used for low load. This is used for low loads. And second is the gusseted base. So two base we have to provide for the column, and we have to design here slab base and gusseted base. So there are two column base. So one is a slab base and another is a gusseted base. So slab base is used for low loads and gusseted base is used for heavy loads. So these two base are used below the column. So we have designed the column in unit number 4. So this column is resting on this base. So what looks the slab base and what looks the how the slab bases look and how the gusset base look, I will show you by this sketch. So here so you can also draw the sketches. So I will draw here sketches. You can draw also. So this is the concrete pedestal. On this concrete pedestal, this is the your base plate. This is the base plate. On this base plate, the base plate is connected to this concrete pedestal through these anchor bolts. So these are the anchor bolts, and this column is fixed. This column is connected to this to base plate. This is the vertical is the column. So this column is resting on this base plate, and the column is connected to base plate by using this cleat angle. So these angles are connected both side of the column, and this cleat angle is connected to column by bolt or rivet. Then this plate is placed on the concrete pedestal. So this is the concrete pedestal. The plate is resting on the concrete pedestal, and the plate and concrete is connected with the anchor bolts. So at each corner, four corners are there for this plate. So at each corner the anchor bolt is provided like this. So this is the slab base, we are calling as a slab base. Now second is the gusseted base. Second type of column base is a gusseted base. So for gusseted base also base plate is provided. Again concrete pedestal is there. The only change is here, this vertical plate, additional vertical plate is provided here. So here this is column and this is the gusseted base. It means to this column additional plates, vertical plates are provided. To this vertical column additional vertical plates are provided on both sides. So we are calling as a gusseted base. This is again cleat angle, this is again base plate, this is again anchor bolt, this is again pedestal. So other components are same, and only the additional vertical plates are provided both the side of the columns. We are calling as a gusseted base. So draw the sketches and see the difference between gusseted base and slab base. This is the concrete pedestal. So this concrete pedestal is resting on the ground. On this concrete pedestal, this gusseted base is provided. Base plate is provided. At base plate and concrete pedestal is connected by these anchor bolts. So four anchor bolts are provided in each corner, and on the plate the column is resting or rested, and to this column the plates are provided. That plates are nothing but the gusseted base, and again cleat angles are connected. So this column is fixed with this gusseted. Here also connections are there. So these connections, and the gusseted base may be connected to column by weld or by bolts. So these are the two types of the column base. First is the slab base and second is the gusseted base. So we have seen the basic difference between the slab base and gusseted base by the figures. Okay, so draw the sketches. So why heavy loads gusseted base is provided? If the heavy loads coming on the column, so we are providing the gusseted base. The reason behind that, the column will, this vertical column will deflect left or right side. So we are providing this gusseted base, and this gusseted base is again connected to angles, cleat angles. So for that purpose we are providing this gusseted base. So is this over? So this is the side elevation. So again I will draw here a plan of this particular. So here this is the your concrete pedestal. Then on the concrete pedestal there is a, this is the gusset plate. So this distance is we are calling A, this distance is we are calling small b. And here we are providing this column. So at each corner this anchor bolts, this is the plan, this is the your elevation. So same structure we can here plan, same plan we can draw here. So again base plate is there. So base plate and concrete pedestal is connected by anchor bolts. So these are the anchor bolts. Then this is concrete pedestal. This is again base plate. This is the base plate, gusseted base is provided. Now this is the length of foundation. This is the width of foundation. Same here, LF is the length of foundation and WF is the width of foundation. Again this is length of plate and this is width of plate. LP is nothing but length of plate and BP is nothing but width of plate. LF is nothing but length of foundation and this WF, or we can call BF also here. This capital BF is the width of foundation draw the sketches. Again, if you see here, this is the depth of section, depth of eye section, and this is the width of eye section. So capital D is the depth of eye section, and this B, capital B is the width of eye section. Here again, this is the depth, this is the B or BF we are calling, width of flange of eye section. So now, have you drawn this? See the various components of the column base. At the bottom, concrete pedestal is there, it means foundation is there. Above the foundation, base plate is provided. Above the base plate, the column is rested, and the column is connected by the cleat angles. In the gusseted base, again you can see here, the concrete pedestal is at bottom. Above the concrete pedestal, base plate is provided. After the base plate, the column is rested, and this column is connected with the gusseted base. Okay, is this over? Have you drawn? Okay. So now we will see one by one how to design the slab base and how to design the gusseted base. So we will see the first procedure here, design procedure for slab base. So first we will see the slab base, how to design the slab base. Some noise is coming from my side. म्हणजे कसं असं जोरात येतोय की कसा येतोय नॉइज? Actually, my laptop is something problem. He's giving the fan is ringing. That's why I think noise is coming. Small noise is coming or big noise is there. Outside disturbance is not there from my side. The disturbance of my laptop, the fan is ringing. Okay. So we will see the design procedure of the slab base first. So write down now step 1. Step 1, we will see the procedure and we will solve. So we have to solve two problems on each, slab base and gusseted base. We have to design slab base first. There are two types of column base, slab base and gusseted base. So we will see the design procedure of slab base and then gusseted base, and we will solve the one example on each. Okay, so now step 1, calculate 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 the bearing strength. Calculate the bearing strength of concrete. Calculate the bearing strength of concrete. It means how much strength of concrete is there. That bearing strength of concrete we have to calculate. So bearing strength of concrete is equal to bearing strength is equal to 0.45 FCK. 0.45 FCK. So where FCK is equal to, it is the characteristics, it is the characteristic strength of concrete. Characteristic strength of concrete. So how to calculate characteristic strength of concrete? So it is depends on the grade of concrete. So characteristic strength of concrete for M15 grade concrete, for M15 grade concrete it is 15 Newton per mm square. For 20 M20 concrete it is 20 Newton per mm square. Like this, the grade of concrete FCK for M40, M60, if for M60 it will be 60 Newton per mm square. Are you getting? For M15 concrete, characteristic strength FCK is here. FCK we have to put here. So value of FCK is for M15 grade concrete 15 Newton per mm square. M20 grade concrete 20 Newton per mm square. Similarly, for M60 grade concrete 60 Newton per mm square. It means M25, M30, M35, M40 for respective 25, 30, 35, 40, like this, these values will come. Are you getting? And we have to put here and we have to calculate bearing strength in Newton per mm square. So this is the step 1. Now step 2. Step 2 is calculate bearing area. Calculate bearing area of base plate. So whatever base plate we are providing, the bearing area for the base plate. what is the bearing area of base plate that we have to, that is the AP. AP is nothing but area of the plate here, base plate. So how to calculate this bearing area? So AP is equal to, so area of plate is equal to factored load on column, factored load on column divided by bearing strength, bearing strength of concrete. Factored load on column divided by bearing strength of concrete. So bearing strength of concrete we have calculated in step 1, and factored load of column, that will be given in the problem statement. So load is given. If load is not factored, we have to factor by 1.5. It means what? Here factored load, if P is there, then 0.45 FCK. In this way we can calculate area of base plate. So this is the step number 2. So now step 3. Step 3. Calculate size of base plate. Calculate or select size of base plate. So we got the area of plate. If the area of plate is there, then we have to calculate the size, length and width, as we have seen in the above figure. We have seen in above figure LP, length of plate, and BP, width of plate, that we have seen shown in the figure. So for that we have to calculate. So first, if the square plate we are providing, if square plate is there, then what is the length and width of this plate? If the square plate is there, then LP is equal to BP is equal to under root of AP. So AP is here we have calculated. So under root of AP is equal to length of plate or width of plate. So plate having 2 dimensions, length and width. So we have to calculate this. We have to use square plate. If we use the square plate, then length of plate is equal to width of plate is equal to under root of AP. This is so simple. And second is the for